Yeah, so today my plan was to take one of the recent AtCoder regular rounds that I haven't done yet. There was one actually that I was thinking of in particular which I had to miss because I was doing Facebook Hacker Cup that day, and just go through it and upsolve it. My fans are loud. Yeah, I think I at least have my microphone set up away from, yeah. It's like somewhat away from the fans, but there's not that much I can do about it. Yeah, just the combination of streaming and um, yeah, just streaming and like also doing regular stuff at the same time is just a lot of things for the CPU. Yeah, this is Ubuntu. Hello, Synad2222. Yeah, Anand is just making a pun. It's a pretty good pun, actually. Am I doing a virtual or just upsolving? I guess I can do a virtual. I mean, I'm planning to just go through the problems, but like talk through them as I'm going through. So I'm not really trying to go for speed, but I could set it up as a virtual just to kind of see how it's going. Definitely will be slower than um, like an actual attempt at going through a contest for speed. Will I do only ARC? So I'm planning to start with ARC and then we'll see from there, but most likely it will just be the ARC. Do I have a dual monitor set up? Yes, I do have a dual monitor set up. So you're only seeing one of the two screens right now. Why are they not releasing English editorial? Yeah, I don't know. I don't know why they won't or they haven't been releasing any editorials there. I think there was some discussion in the thread on Coforces, so we can just see about that. Gravity Destroyer, I won't be looking at problem requests right now, but maybe sometime in the future. Yeah, but yeah, another exciting thing about this stream is this is the first time I'm streaming as a Twitch affiliate, which means I now have a subscribe button below, as well as channel points and a couple other features. So hopefully you can all see that right now. Oh, awesome. Thank you, Anand, for the sub. First subscriber. Channel points are the thing you should see in the bottom left of the chat, where you have kind of I guess it's like a circle, and then you have a number there. Hang on a second. Oh, what it does? Yeah, so if you get enough, you can do certain rewards. I think one of the common rewards is hydrate, where you can make me drink water, which is kind of funny. But yeah, there's a couple other ones in there. I might switch it up from time to time, but you have it in there now, so you can check it out. Can I upload the last Codeforce educational? Yeah, so the last educational round is already on YouTube. Let me link it here. Oh, looks like we already have a hydrate from Synad222. All right, here we go. Yeah, the educational rounds are already there, so check it out. All right. Yeah, so we can just get started pretty soon here. I guess I'll set up a virtual. Okay, I'll just have it start in about 1 minute. Oh, did the stream just drop for a bit? Which city am I in? So I'm usually in the Bay Area, so Northern California, but just kind of for the past while, I've been back in my hometown in Louisiana. I see, yeah, okay, so hopefully we don't have any more freezing issues. Um, I see, yeah, but it sounds like it's good now, so we'll just kind of go forward, fingers crossed that it's still working. Yeah, I think it's just not solving the problem before you're virtual and submitting it. Not the template's banned. Okay, yeah, it seems like we're good now. Yeah, Gravity Destroyer, I mean, practicing is basically the only way to do that, and just, you know, doing problems and learning from your mistakes. Do I ever do ABCs for fun? I don't do ABCs super often, partly because AtCoder timings are just really early for the United States, or just all of North America, really. And yeah, so I kind of only wake up early if it's an ARC or AGC. Yeah, Konarkle Hat, you could totally be the second sub. If you don't hurry up, you might be the third sub. So we'll see. I don't know. Maybe it's not that fast. Okay, let's look at the first problem. So we've got an integer n. It's only between 2 and 30. One integer x. Yeah, I'm seeing the occasional stream drop. I guess my internet is not the best right now. Hopefully it holds up. So just gonna jump into the problem and hope that we don't have too many issues. So print an integer x between n and 10 to the 13th such that for every y between 2 and n, the remainder when x is divided by y is 1. Okay, so basically we need a number that is 1 mod every number between 2 and n. Another way to think about this is if you subtract 1 from x, then x minus 1 is divisible by every y from 2 to n. And so one obvious thing we can do for x minus 1 is to make it equal to n factorial. And that way n factorial is definitely divisible by all of the numbers 2 through n. The problem is 30 factorial is pretty big. It's definitely more than 10 to the 13th. It's like, yeah, 10 to the 32. And so that's not going to be good enough for this. But again, the requirement we need is just x minus 1 is divisible by every number between 2 and n. So actually we can make it equal to the LCM, or the least common multiple, of every number from 2 to n. Trying to find the Wikipedia. Yeah. So this is just a general article about this concept. You can find this number by doing by multiplying and dividing by the GCD. So the way that we would implement this is actually, let me see. Let me make a folder for this round and then just set up some files. Okay. So yeah, so we're gonna read in n. Oops. Grab my keyboard. Okay, we're gonna read an n, and then basically we're gonna start building our answer. And then for every number from 2 up to n, we're gonna take the LCM of answer and x. So maybe I'll call this LCM. And the way we do that is just yeah, basically it looks like that. Oh, Clang is giving an error for underscore GCD because this is only in GCC. But yeah, this is the general formula for LCM. LCM AB equals A times B divided by GCD AB. The reason for that is just if you multiply the GCD and LCM, if you think about the prime factors, basically the GCD is for each prime p, the GCD has the minimum exponent and the LCM has the maximum exponent, and so the product is going to be the same. The audio is desynced. Is the audio coming too early before the video, or is the audio coming too late after the video? D and 1030 seems fine. Yeah, a couple of people saying audio's not in sync, so yeah, refresh and let me know if it's still an issue. Cyanide222, the audio is early. Okay, a couple of people are saying it's early. Oh, we gotta hydrate. Okay, one thing I can do, I can actually just delay the audio a bit more. Audio is fast, audio is faster. Seems that it's fine. It works on refresh. Okay, maybe I will a little bit, but not too much. Okay, I delayed the audio a little bit. Hopefully it's a little better. Okay, so there's 2-second delay. Maybe you need to refresh then, because we have some people saying that it's not an issue. Can I use standard GCD? Oh, I see. This is only... Right, you're right. This is only available since C++ 17. And yeah, so usually, personally, I don't use things that are only available since C++ 17, just because, you know, a couple of different competition platforms have different versions. So that's why I'm used to using this. Yeah. And then one thing I was going to say is it's slightly better to do the division first before you multiply by x, and that helps prevent any overflow. So let's check. Oh, I see. The problem is we need to make this also an int64. Oh, actually, Clang does have... I guess I was wrong. Clang does have... what do you call it? Underscore GCD. So we just want to make sure 3 is set. Oh, I forgot to add 1. So, of course. Okay. So 3 is 7, and then 10. I mean, oh, this number is kind of unnecessary, but we just want to make sure 2520 is divisible by 1 through 10. And yeah, if I recall correctly, that is the LCM of 1 through 10. And then let's just make sure the number for 30 isn't too big. And that looks about like a reasonable size. GCD is the log time Euclidean algorithm. Yeah, so it's quite fast. Underscore GCD, I mean. I think standard GCD is probably also similarly fast. I guess it doesn't actually mention here the time complexity, but I believe they're making it, you know, fast. Okay, so we can go ahead and submit this. LM10 Piyush, when you solve Z, please give some time on it. Yeah, sure, I will go through every problem and just explain my thought process. Okay, so problem B. So S is concatenating a lot of copies of the string 110. So for example, 3 copies is 110, 110, 110. We have string T of length N. We want to know how many times it occurs in S. Okay, so this number is actually important. Often when you have a problem like this number isn't super important. They just are basically trying to put in infinity. But we do need to know relative to this number. So for example, right, a lot of these numbers are like almost 10 to the 10th. Yeah, okay, find the number of times it occurs as a substring. So yeah, basically the string has to have a bunch of, if the string is actually long, it's going to have a bunch of 110s concatenated. And then if we think about where the string starts, there's only 3 options basically for where the string starts in some sense, which is either on the first one or the second one or the 0. And basically the thing is that if your string can start on this one, then it can start, you know, on this one or on this one and so on, up to the point where the length actually makes it go past the end. And so we can kind of just do a loop of 3 potential offsets and count how many ways you can start at that type of offset mod 3. So if we pull this up, basically, yeah, so let's just read the string. And then we're going to go through potential starts. And first we're going to check if it's valid. So for each character from 0 through n-1, we're going to compute want, which is basically so the index that we would want is start plus I, right? And then the character we want is, it's basically, it just depends on index mod 3. So it's just index mod 3 if it's either 0 or 1. So if it's less than 2, then we want a 1, otherwise we want a 0. So hopefully that makes sense to people. Basically, the idea is we have 110, 110, 110, right? And if t is equal to, for example, you know, 0, 1, 1, 0, 1, 1, 0, then if we're trying an offset with start equals 2, we're basically comparing it to this, to this string. And so that's why we add start plus I, and then we can compute the character we want based on that. What keyboard do I use? So I use a Microsoft Natural Ergonomic keyboard. It's this one right here. And it's actually it's pretty big, but I like it just to, have the ergonomic setup and to, I can just put it on my lap because it's pretty big. And it's not a mechanical keyboard, so it's not super loud, but people have still told me that I type pretty loud. That thing is thick, yeah. Okay, so valid is going to be valid and ti is equal to 1. And then now, first we need to check if it's valid. If it's not valid, we just don't get any substrings here. But if it is valid, then basically we get a number of substrings, which is equal to basically the number of things that are equal to this mod 3, but what was this? Oh, 10 to the 10 copy. So the length is actually 3e10. Yeah, 3e10. Okay, so basically we're going to try to find the last index, which is the point where we want to count all the indices where index plus n is less than or equal to length. So in other words, index is less than or equal to length minus n. And it has to be the right value mod 3. So basically we can do something like this. This is the last possible index, and then while last index mod 3 is not equal to start, we can do that. And then finally, so last index is the last valid index, start is the first one. So we subtract them, divide by 3, and then we have to add an extra one. Because, for example, if start equals 2, last index equals 8, then we have 2, 5, and 8, which is 3 choices. So that's why we add 1 at the end, because basically 8 minus 2 divided by 3 is only 2. We're only counting everything except what. Okay, so let's try running this. Looks good. Is that the right number of letters? Yeah, that's right. And then this right here, yep. And then if we give it like something totally wrong, it should be 0. Okay, yeah, that looks good. Oh, increase the font size? Yeah, we can do that. It should be better. Do I want to upgrade to some exotic ergonomic keyboard? I don't have any desire at the moment to do any super crazy keyboard. I've seen some crazy ones. I think it's called the Kinesis keyboard. Yeah, I've seen people use these, and these are they seem pretty hardcore. And I tried using one of them at one point, and it was just not, like, it was just no good for me. I think it would take like a couple weeks to actually get used to it. Can you please make a video about your setup? Yeah, I've had some people asking me about that. I might do that at some point, but how do I build multiple files? That's a really simple script. It just looks like this. Well, this is kind of some extra flags, but basically it just like, there's just some template file. It picks which one, and then it just copies it over and opens it in Sublime. Yeah, and that's something you can make yourself. I mean, another thing you can do, honestly, is just make a template file and then copy it over a bunch of times. The Ergo docs looks cooler. Okay, let's check this out. Oh, I see. It's like the same setup with these weird middle keys that I don't like. But not all of the like giant empty space. Yeah, I see what you're saying. Versus like all of this stuff. Yeah. Yeah, I'm good here with my absurdly long name keyboard. It's the Microsoft. I think it's the Microsoft Natural Ergonomic Keyboard 4000 for business. It's kind of a ridiculous name, but I do like the keyboard. It's a nice keyboard. Okay. Oh, did we submit this? I think we didn't submit this yet. So let's go and do that. And hopefully we did not overflow anything. I think we're good. Okay. Looks like we are good. Have I ever considered using Vim? No, I've never really been big in Vim. I actually, back in high school I used to use Emacs, so total opposite end there. Looks like we got some spam here. Looks like my current view doesn't have mod tools. Let me switch over. Okay, took care of that. Okay. The mechanical keyboard game is a giant money pit. Yeah, that definitely sounds like that is the case. I have seen people paying like, I don't know, $500 for a keyboard. Okay, let's look at problem C. Or maybe let's see how we're doing. Oh, maybe this is the overall standings. Maybe I want the virtual ones. I'm not sure what's going on here. I think the stream is still up, so maybe it's just the... Oh, this is just the overall standing, so it's not really what I'm looking for. I guess this is kind of interesting. A lot of people skipped E. Actually, F has more solves than E, so I guess we'll run into that later. For now, we can go back to C. So, oh, or maybe I missed virtual standings. Okay, yeah, this is virtual standings without faves. Okay, so we are in 12th place. Okay, we'll see if we can move up a bit. So we've got a permutation of 1 through n. Okay, we want to sort it. Oh, we can only use n-1 swaps, but we can change the order that we use them, and we want to sort it. So, okay, the first thing I'm thinking is the number of inversions of the permutation has to be at most n-1. And Jallo Trashbim asks, can you discuss C1 and C2 from Globeron 12? What was my thought process for the problem? Well, I mean, I didn't get C1 and C2, so my thought process was just, it was just wrong. I was thinking too locally when you need to think more globally, which is kind of funny given the name of the round. But yeah, you need to think more globally about all the diagonals, modulo 3. But yeah, I did not get that problem. Oh, hello, Crow. We're just doing ARC 110 right now. Oh, maybe we can update the title to put the round number. Might take a while to load. Yeah, I'm not sure what's going on with my internet. It seems like the stream is fine. Oh, is Codeforces down? Oh, no. I think we're good. Oh, it looks like Ericto is streaming at the same time. That's surprising because I put this up yesterday and there was nothing up there. Okay, so yeah, that looks good. Okay, so back to this. Yeah, we're looking for, they want the sequence. So swap 5 and 3, swap 4 and 1, 4 and 3, and then 1 and 2. Oh, and then -1. Oh, that's not, Oh, thank you for the sub, Scott. Scott has all the badges now. Oh yeah, IRL word ban. Yeah, I was just looking through the different options, and that seemed like a fun one. Yeah, we'll see how that goes. It might be too difficult. Scott, what sub number are you? You are the second sub, so Anand was the first sub. Oh, we gotta hydrate. Okay. From S0MF. Redeem Java. Yeah, I'm not great at Java. I don't know if you guys really want to see me coding Java. Someone asked, GM Mark Zuckerberg asked, what is my chess rating? So I'm not super good at chess. Just play kind of casually. I think on chess.com I'm like something like 12 or 1300, not super high. But I do like doing chess puzzles. It's kind of fun. Maybe I'll do chess puzzles like after this ARC. We'll see. Okay, so back to this problem. I guess we can close these. So maybe we can think about going in the reverse direction with this. So let's start with the sorted thing and just, do some random swaps and see what happens. So I'll swap these two, and then maybe I'll pick these two, and then maybe I'll pick these two. Maybe I'll pick these two, and then I'll pick these two. So one thing I'm noticing is like, I just tried a random sequence, and every time I did a swap, the first number was smaller than the second number. And now I'm wondering if that's always true. Yeah, I think that is always true, because basically if you think about, two consecutive numbers in the sequence, you can only do swaps. If you haven't done this swap yet, you can only have done swaps on this side and on this side, which means when you swap these two numbers, this number will be between 1 and 3, and this number will be between 4 and 6 for sure. And so what that means is every time we do a swap, we are definitely adding one inversion. Inversions are number of pairs ij where I less than j, but ai is greater than ij. So it's the number of pairs in the sequence that are basically out of order. The reason that matters here is because every swap that we're doing, in this sequence we're going in reverse, so we're going from sorted to not sorted. Every swap we're doing adds one inversion. And so the other way around, if we start from the unsorted thing and we do the swaps, every swap will have to remove one inversion. So I think we can only solve the problem if basically there are exactly n-1 inversions. I think the question is whether anything with n-1 inversions will work. GM Marks, yeah, puzzles are super fun, definitely. 1v1 chess for 5k channel points. Yeah, I could make that as a potential reward later. GX Fireball. What link are you looking for? Are you looking for? Oh, let me do this. Okay. Okay. Yeah, and so if we think about like the most extreme sequence with n-1 inversions and see if we can do it, you know, it would be something like 2, 3, 4, 5, 6, 1, where we put the 1 all the way at the end, or maybe like the other way around, 6, 1, 2, 3, 4, 5. And, you know, both of these we can do because we just, we swap these two, and then we swap these two, and so on. And so we're just kind of basically just like insertion sorting things. And then maybe in general, I wonder if in general this just works. What if we have like 3, 4, 1, 2, 5, 6? Maybe this? Is that in the inversions? Yeah, that is 5 inversions. Oh, that's interesting. I think this might be... Yeah, I think this one is no good because basically we should never swap this pair. Like we should never swap, we should never move the 6. So what's really going on here? Can I share that Kofusa script? So this one, I mean, it's a lot of it's like pretty specific to my setup because I have a certain, you know, template file. I think, you know, for you, you'd probably be better off just like, just learning some like basic scripting and setting up your own version. I mean, even if I share this, it like wouldn't exactly work for you because it, I mean, you know, it relies on this specific template file or like opening up some blind text via this command, which is like a custom command that I set up. I think normally it's just subl. So yeah, I think the better thing would be to just like learn some basic scripting. You can use bash if you are running on bash, or you can use Python or a number of other things and just set up a script to like copy a template over. Isn't the order the harder part of the problem, or is it obvious when you know it can be done? So, well, a couple things we've said so far are, one is for sure it has to have n-1 inversions. And then another thing that I can say that we need to have for sure is that basically the problem with this sequence is that if you like cut it here, then everything here is less than everything here. And what that means is we can never do the swap that crosses here. So it's kind of like, so what I'm thinking now is we need a sequence where if we check every dividing point, you know, we can have like a lot of inversions, but if there's some dividing point that cuts the sequence into smaller on the left and bigger on the right, then we have a problem. And so now what I'm wondering is if we have n-1 inversions and we don't have any such dividing point, are we good? And my guess is that we are good. But let me see if I can figure out why. So I'm looking basically at this again. Yeah, so basically if we try cutting the sequence at any point, if we have a valid sequence and we try cutting it at any point like this, there should be there should only be like one pair of numbers that we need to like have cross each other here. So in this case, for this one, it would be 4 and 2. Basically 4 and 2 need to swap sides, right? And I think if we cut anywhere else, we also see the same thing. So here 1 and 3 need to swap sides. If we look here, then 2 and 3 need to swap sides. We just did this one. And then if you look here, 2 and 6 need to swap sides. And here, 5 and 6 need to swap sides. And so what that means is if we do the insertion sort, we'll just end up with the case where basically every swap will cover each pair once. And so what that actually means is that we can just run insertion sort on the array and just make sure that the conditions of the problem do occur. And if they don't occur, then basically it's not possible. So let me see, we want to do, right, okay, so I guess we'll just start making a vector of swaps. And then we'll go through each index and we'll just run insertion sort. We're just going to go while pj is greater than pj, is less than pj minus 1, because that means they're out of order. And then while that's the case, we'll swap pj and pj minus 1, and we'll add that to swaps. And then if swaps.size is ever bigger than n minus 1, we're just going to break. So I guess we can actually just do this instead. And that way we make sure we're not actually running an n squared time. Because if we would have to do a lot of looping, then this would get big enough that we would just quit. And then the last thing is just to make sure that it's unique. So yeah. And yep, otherwise we are just going to print out our swaps. So if we run it on this, so we actually got a different order, but I think it might be fine. Let's see, 2, so we swap that. So we get 4, 2, 1, 5, 3, and then, oh, no, that's this. So we get 2, 1, 4, 5, 3, then we swap 1, so we get 1, 2, 4, 5, 3, then we swap 4, so we get 1, 2, 4, 3, 5, and then we swap 3, 1, 2, 3, 4, 5, so it looks good. This one should be -1. Yeah, so I think we are good here. Yeah, so one thing to notice is I didn't actually need to code an inversion counter, which takes n log n time, and you have to use something like birch sort or Fenwick tree or a couple of different options. But here instead I can just run insertion sort, and the number of operations that insertion sort takes is literally the number of inversions. That way we can just Uh, that way we can just track that as we go, and if it gets too big, we just break. I don't. S0MF says I don't think we need to maintain, or I think we don't need to maintain the swap vector. We can count the swaps directly. So we need this because we need to print it out at the end, and that's the main reason. Otherwise, we could have just, had this vector bool before and done that. If the problem just asked for like yes or no, then we didn't need it. That's right. But because we need to output it at the end, then we just keep it. So let's submit. Oh, looks like we got a wrong answer. It'll take a little while, and then we can see how bad it was. So we got a lot of ACs, and we got maybe a third wrong answer. So let's go take a look, see what's going on there. So, oh right, I did something dumb. So I forgot to check that this is exactly n-1. So if it's less than, then we should also print -1. So for example, if we don't have this, I think the problem is, yeah, it didn't print -1. So that's the problem. And then once we put this in, it should be good. Yeah, and then similarly, if we have like 1 inversion. Yeah, so the problem is basically earlier without this, if we give it this, it'll just be like, oh, you just need to do 1 swap. But that's not an option here, so we need to make sure that it's exactly the right size. I guess we can just do this. All right, so let's submit that again. Yeah, just a silly mistake that costs a little penalty. It's looking good now. Okay. So we can move it on to problem D. I know someone asked about it here. I guess that's a while back. Okay, so let's just look at this. Okay, we have a sequence A of n non-negative integers. Compute the sum of bi choose ai over all sequences B that have a sum at most m. Print modulo 10 to the 9th plus 7. Okay. Okay, this looks like a pretty good sample. It's just the digits of pi and then the NTT mod. But anyway, it looks like passing this means you basically know what's going on. Yeah, so I think I think we can probably find some sort of combinatorial interpretation of what's going on here. We got a hydrate. That's funny because I was actually getting the water anyway, and before I even saw that. But just, get a 2-in-1. Okay, so the sum of bi is at most m. Yeah, okay, so so one thing we can do here is just think about it combinatorially, try to come up with an interpretation. Another thing is, yeah, we could throw some generating functions in, and that would also make sense. Okay, so it's almost like picking the sum of the AI elements out of kind of M elements. Um, but then we're kind of counting the number of ways to have a certain number of like boundaries in between. Okay, so I think we can handle sum is at most M by adding a 0 to the end of the AI sequence. What that does is basically if the sum of, or like, yeah, we take the sum of B and then there's kind of an extra B that is M minus the sum. And from that one, we just choose 0, which is just 1. And so that doesn't affect the overall product, but that simplifies things to make it exactly M. So yeah, so basically the first thing I would do is just append a 0 to the sequence. And actually 0 is already allowed, so that just keeps it like cleanly within the range of allowed inputs. Can I explain it one more time? Yeah, so we're trying to deal with the fact that it says sum is at most M rather than sum is equal to M. So one thing we can do is let's just add a 0 to the end of the AI. So we'll make the A sequence one bigger. So instead of 1 2 1, it'll actually be 1 2 1 0. And then we'll require that the sum is exactly equal to M. And the reason that works is basically if we think about a smaller AI sequence where we get this BI sequence, the sum of the BI, let's say it's less than M, then we can add another, like we can add a BI or add a B to the end, which is just M minus the sum. And since we have an A at the end, which is 0, we'll just multiply this by something to 0, which is just 1. And so that basically converts the problem to a problem with n plus 1, where we want exactly this sum. Another way to think about it is if you think about the combinatorial interpretation. So basically this problem is like, okay, we have M kind of slots, and then we want to pick sum of AI of those slots, and then between certain pairs of the slots, we also need to pick a divider, a location for a divider that goes in between them. Let's see, maybe I can draw this somehow. But yeah, I'm also just kind of like thinking through this problem myself still. Maybe I will, okay, I guess I can run like Pinta. Hello, Juby74. Okay, so basically if we think about the BI as, maybe I can draw rectangles. Oh, that's just a selector. I won't actually draw it. How does this work? Okay, I'm not really sure how this works. I think I just made a bunch of stuff. Okay, that's unfortunate. I guess I will just draw them. So if we think about, oh, that's the problem. Am I drawing in white or something like that? What's happening? It's not letting me drag for some reason. This is super weird. This was definitely working earlier. People are recommending different tools to me. Color picker. No, that's not what I wanted. Oh, no. I can draw one point, that's it. Okay, this is super funny. It's not very helpful, but not sure what's going on here. Maybe let me try closing it and reopening it one more time. Okay, that's super weird. I don't know what happened, but looks like we're good now. I will zoom in some more. Just click real often and draw point by point. Yeah. We could have done that here, but you know, we might be here for an hour just drawing. Okay, so maybe we can use the rectangle now. Let me see. Oh, nice. Okay. No, we don't want that. Okay, so, and then hand, yeah. Okay, apparently this doesn't do what I think it does. Okay, anyway, we'll just go with that. So if we say that these are the BI, so this is B0, this is B1. Basically, the size of each of these is the B. Then we're picking, you know, A0 things from here. So I guess if we draw like a couple lines. So maybe this one is 5. This one is 7. What is that? That is gross. Oh, I'm erasing the entire background? Okay. This program is very strange to me, but anyway, we'll just keep going. Let's say this is let's say this is 2. So basically B0 equals 5. Wow, this program is not being very nice. This is Pinta in Ubuntu. I think it's like supposed to be like Paint, but it's not cooperating very well. Yeah, some of these are very strange. Like what is this? Who wanted to erase the background? Like I can't think of any use case where I would want that. Anyway, okay. So this one is 5, this one is 7, and this one is 2. And then, you know, maybe we're picking a couple of these. So, you know, let's say A0 is 2, then maybe we'll pick this and we'll pick this. Let's say A1 is 3, you know, maybe we'll pick this and then this and then this, and then B2 is, or A2 is 1, so we'll pick this. What I was saying earlier is, in order to handle the sum up to m case, we can just make another rectangle. This one is basically B3 equals m minus. Okay, we went off the screen, hopefully. Oh no, I don't know how to move it back. Okay, just delete that. I will redo it here. Oh, I missed the hydrate. Oh, sorry about that. ACD Hemtoss. All right. Yeah, well, this is a very janky Paint app, but we will give it a try. So basically, B3 is m minus the sum of the other ones, and then A3 is also 0, and so that kind of helps make the sum exact. He just paid 300 for hydrate. How do I do a half hydrate? Maybe I'll just do a real quick one. All right. Yeah, hydrate is out of stock because it has a cooldown, so you can only do it every so often. So people can't just spam it every 2 seconds. Yeah, so basically the idea here is, what happens if I... Oh, I guess that's just stupid. Okay, the idea here is we just have M slots, so it's like we have one big rectangle of size M. No, that was fine actually. We can just that. And then again, we have like these lines and so on. That's a bit far. And so on. And then we're going to pick basically some of the AI points here. So this corresponds to this. And then now the key thing is we need to choose, I guess we need to choose n dividers between them after we do that. So like in this case, we choose this divider, we chose this divider, and we chose this divider. And that's how we pick the BI. Oh, hello, Saket. All right. Got another hydrate. Wait, did you guys already have channel points like from previous streams? Did that end up counting here? Otherwise, how did you already get 200 points? Yeah, so the way I want to think about this is basically we pick these points and then we're also picking like the dividers are like almost like picking points in between some of the other points. The only thing is that we have one more option than if it were an actual point. So this divider, for example, it could be here, it could be here, it could be here, it could be here, right? Whereas if we want an additional point here, we would only have 3 choices. So maybe there's some way to factor that in. I think what we can do is we can treat it as like a row of m plus n slots, and then just pick some. So m. Oh, that's really bad. All right, we'll use text. M plus n slots. I don't know why that is so blurry. That is so weird. And we're choosing sum of AI plus n. I guess technically this should be n minus 1, but we're adding another element to A, so the number of gaps in between them is kind of like n of them. And then we can show that there should be like a bijection between these, where basically every time we pick one of the divider numbers, we're just like, essentially we're going to kind of squish one slot at that point. Alex BK95, this platform doesn't have sub. So Twitch definitely has subs. You should see a sub button on my channel. YouTube also has subscribing. So YouTube subscribing is really more like following on Twitch. So they're a little different. So maybe to show a more concrete example here. Yeah, so 3, 5, 1, 2, 1. Okay, so for the actual example we're given, here we have 5 slots using this. So m equals 5, and then we need to choose like essentially 1, 2, and 1, and then pick some dividers in between them. So one arrangement could be like, something like this, and then pick two dividers. We could pick something like that, and then something like that. And that corresponds to, this basically corresponds to b equals 2, 2, 1, right? And that's because it's the dividers in between them. And then we could also pick b equals 1, 2, 1 and have a total of 4. And so the way we handle that is, instead of a being 1, 2, 1, we have a equals 1, 2, 1, 0. And so now, essentially what happened here is we actually have an extra divider here, and then there's basically a 0 here. So in the b equals 1, 2, 1 case, oh right, forgot. In the b equals 1, 2, 1 case, we're actually doing this. Divider here, and divider here. So b ends up being 1, 2, 1, 1. And then that satisfies a 1, 2, 1, 0. And this b is actually 2, 2, 1, 0. I think I can't... Yeah, this is really unfortunate. I don't know how to go back and edit the previous ones. Oh, you can go back in time, but you can't actually modify. Okay. Yeah, I probably will look for a new paint app, because this is not. This is very funny. Like this background thing. I don't know who designed that, but yeah, these are not the features that we want. Callo Valera, thanks for the hydrate. Yeah, I'll look into it at some point. Okay, so which convex hull algorithm do I use? So I use a couple different things, but if I'm just doing straight convex hull, I usually use gram scan, so you can check that out. It just kind of finds the bottom point, sorts them, and then goes around and builds a stack. But anyway, I won't get too into that right now. So here, basically, to kind of finish off the problem, how do we pick the dividers? And looking back at this, it's almost like picking another point in between the points here, except that there's one extra choice compared to picking points. And so we need to expand the slots, and that's why we do m plus n slots, and we choose some AI plus n of them. So in this case, I'll just give one example on this sample. So we would have something like this, where we want 8 slots. I'm not sure if that's what we're getting here. Okay, that looks pretty good. That is 8 slots. And then we're choosing sum of AI, which is 4, plus n of them. So we're choosing kind of like 7 of them here. So we could do something like this. Yeah, and so then what that corresponds to is, since the first A is 1, then this point is actually a divider. What that means is we have a point here. That's our first point. That corresponds to this. This point corresponds to this divider. And then these 2 points would be the next 2 points. So also we need to shrink everything by 1. So we kind of delete this square. So we have empty and then point, point. And then this represents the next divider, which is right here. Right, so again, we like shrink this square, and then so we have another point. And then finally, this is the last divider. We delete the square, and then this is a divider. So this actually is, this is very similar to this case here, except the divider was here. And so that's why we're expanding it. It's a little tricky to understand maybe, but you need to think about just like how there's kind of a bijection between the ways to choose one thing and the ways to choose another thing. Right click on my background and set, oops. I'm not sure how to right click on the background. Maybe layers. Alex BK, in your YouTube channel, when you open the video, could you use automatic captioning? I think that's just an option you can pick on YouTube. Like you can just choose that yourself. Okay, so we will get into coding this. Basically, what do we need here? We need we basically need m. It's like m plus n, choose sum of ai plus n, right? Which, so for this example is going to be something like 8 choose 7, which is 8. And then for this example, it's going to be something a lot bigger. But anyway, I think the easiest way to code this, let's get our mod int here. So this is just a class that does mod operations. We get 189 plus 7. And then we'll read these in, and then we'll have a sum as we're going. So the funny thing is the individual AI don't matter. It's just a sum. And so we're just computing this, choose this. So we can kind of go, in some sense, it's like we want n choose r where, so I guess I'll use little n here, and then sum plus n. And so we just wanted to compute this choose function. They guaranteed us that the sum is not too big. The sum is at most like 4 million, so we can just do this by iterating. And we're just going to do that. I guess we might want to do a case where if n is less than r, then choose which is 0. Equals choose times n minus I divided by I plus 1. So we're just using the choose formula where you multiply r things on the top and then r things on the bottom. And then we'll just go for that. Let's try running it. Okay, that looks pretty good. Let's check the case where like n is too small. And just make sure it's 0. Okay, that looks pretty good. Oh, we've got to hydrate. Okay, we got it. Definitely going a little slow here. Just going through the thought process. I'm not sure if we'll have time to do E or F, but we can give it a try and see. Okay, yep. So again, yeah, we saw in the standings that F is more points, but E was actually harder. So I may actually look at F instead. But I will just read both problems and see first. This is Anonimo Beginner in practicing random problems. Is this a good way or any better way? Yeah, I mean, practicing random problems is fine. Just make sure they're about the right difficulty level for you. Something similar to your rating or a little lower, a little higher is fine. And yeah, just make sure you do the problems and think about kind of the more general ideas there, what you can learn from it that you can apply to future problems. Okay, so let's read this. We have a string s of length n, consisting of a, b, and c. You can choose any I where si is not equal to si plus 1. Oh, I see. So you can pick any adjacent pair and replace them with the, if they're not equal, and then replace them with the missing character. Find the number of distinct strings that you can be after 0 or more operations. Oh, so for example, AB, AAC, if we pick BA, then we'll get ACAC. And if we pick AC, we'll get ACB. And then, oh, this looks like a pretty good example just to help you make sure you did it right. Okay, so yeah, my thought process here is that maybe there's some sort of like invariant that you can think about where this operation doesn't change the value of that invariant. Yeah, for example, if it's like some sum of the strings, maybe mod something, and even replacing AB with C doesn't change that sum. So you can think about things like that. So let's also read F. Okay, so we've got a permutation. Well, swap pi and pi plus pi mod n. You want to sort in order with this operation. Can make it instead. You can use at most 2 times 10 to the 5th. You don't have to minimize, you need at most 2 times 10 to the 5th. Okay, so n is not very big, and you get a lot of operations. So it's interesting. I wonder if it's actually always possible. I noticed they didn't give a sample where the answer was -1. It might be possible to prove that you can always do it, and maybe you can do it in like something like O of n squared operations. These are just guesses. So yeah, it looks like these are both interesting problems. Yeah, so maybe just in terms of you know, like an actual trying to do well, what you would want to do is if you saw, you know, this, you'd probably want to go for F because it seems easier and you actually get more points. For example, there's people who got A, B, C, D, E, and then unfortunately they lose the people with A, B, C, D, F, even though F is easier. But yeah, maybe I'll take a look at F. So this thing seems really weird to me. So one obvious thing is if pi is 0, then this doesn't do anything. So if you want to move the 0, then you'd have to, you can't pick I as the, like you can't pick pi equals 0. You would have to pick another I where this is equal to 0. Yeah, the CSES problem set is pretty nice. It's good for, very good for beginners as well, because it starts with some very simple problems and then gradually ramps up. And it has a nice like kind of difficulty curve where there are a bunch of different problems on each topic, and each topic gives you problems from relatively easiest to relatively hardest, and yeah, you can learn a lot of different things that way. The later problems are definitely pretty hard. I've actually done all of the problems in like the end of the sequence, and they're pretty good. So I do recommend checking it out. I haven't read the book, so maybe someone else in chat can answer that for you. Okay, so let's see what they do here. So P6, which is 5, with P6 6 plus 5 mod 8, which is 3. P3 is 6. So they swap the 6 and the 5. And you get this. Then you pick I equals 0. You swap P0, which is 7, and P7, which is 3. So you get this. Then you do 3. Swap P3 equals 5 with P0, which is 3. You get this. Finally, I equals 0, P0 is 5, and P5 is 0, which is this. Okay, so if we're just thinking about the array, if you pick a number, like if you pick 1, you can actually just keep like pushing it forward by 1, because you can swap it with this thing, and you can swap with the next thing, because that's basically what it does. So each number can kind of just jump forward by this amount. And then the thing is, like, some of them, if they're not relatively prime with 8, for example, or with n, then you can't move them anywhere. Like with 2, you can only jump it to here, or jump it to here, or so on. So, yeah, this is really weird. So everyone has kind of a cycle that they can jump around in. 0 cycles with itself. So 4 can like jump to here and then back to 4. 2 can kind of jump around this cycle, all of the like even indices. And then you can also kind of use any number relatively prime with n to just kind of push things around. So for example, if I want the 4 to go to an odd index, I can like use 1 a bunch of times and then get it to here. So yeah, for any particular number, you could get it to where you want it to go. So like for 6, for example, I want 6 to be here. So I could do the 1, I could take 1, push 1 forward twice. 6 would start here, and then basically if you jump by 6, you go here, and then you'll go here. But then the thing is that if you just repeatedly do that for every number, you'll probably end up messing up some of your old numbers. Oh, Calavera got a hydrate. Okay, so it seems like the factorization of n could be important. So each number kind of represents a cycle that we can rotate. The number 1 is just kind of the straightforward cycle of the numbers. 3 is like 3 and then 2 and then 0 and then 7 and then 6 and then 5 and then 1 and then 4 and then 3. So it's kind of like jumping by 3 each time. Yeah, and we can pick any... Oh, it's not exactly rotating, it's like taking the number itself and like rotating it around the cycle. So one thing I'm thinking about now here is, what if we got 1, 3, 5, and 7, where we wanted them to go, which are all the numbers relatively prime with n, and then after that we kind of get everything that's a multiple of 2. I guess in that case it kind of becomes the same problem for n equals 4, which is interesting. That's only true here because n is a prime power. Like, what if n is 24? We will have to take care of the case where both integers show same mod than -1. What do you mean by that? So I'm gonna actually solve this problem in 9 minutes. That's pretty crazy. Maybe he's seen something similar before. Can we generalize this somehow? It's kind of like so for 2, we can take the number and we can think about like 2 and then 4 and then 5, and we can replace 2, 4, 5 with 4, 5, 2. So we kind of rotate it where 2 goes to the back. Got a new hydrate. P6y and P6 plus 6 plus 5 mod x is also P6. Yeah, I'm not sure what you mean by that as your MF. It's it seems like weird notation. I'm not sure what P6y means or what x is. Hello, Java King X. Yeah, so if you pick the 0, then there's no swap. So what if we took this and we tried to put 1, 3, 5, 7 in the right positions? So we could do the 7, and we would get that, and then we can do the 3, we get that, and then 5. 5 is kind of inconvenient though. If we do 5 3 times, then it gets 3, 6, and then 0. Comes 3, this one's 6, this one's 0, and 5. And then our 3 is out of order again. Right, that's unfortunate. And then what happens to our 5? So 3 and 5 kind of keep... oh, no, wait. I think we go... Right, we go here. If we do the 5. Yeah, so I don't know, this type of like greedy strategy seems not so good. Maybe to get 1, 3, 5, and 7, we need to like... We need to use 2 somehow. So we can get 2 into the right position. And then I guess we'll just try to position 1, 3, 5, 7, a bunch of them into the right positions. So we could do like, so then 1 in the right parity. So we want like here, 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 here. We want everything except for 2 to be 1, 3, 5, or 7. I guess 3 is already good. We can like do 7, which replaces 3, and then do 3. Or we could do 1 a couple times, and then do 3. Okay, I'm not sure if we have that totally generalized, but yeah, so now we have 3, 1, and 7 here. What does that do for us? Oh, we need to get them in the right, like, relative order, too. That does make this pretty weird. I'm not sure if we're on the right track or not here. Maybe we need to think about some way to like transform the operation somehow. A different way to think about the operation. So another operation you can do is like rotate things to the left. If you did this, if you picked a certain PI and did the swap n-1 times, or I guess not exactly n-1, but like n over the GCD -1. Yeah, that way you can get any rotation of a cycle. So like one way to think about that is if we have the 1, we can look at the rest of it, 2640537. We can kind of rotate that any way we want, and then we can insert 1 anywhere we want. And if we picked 2, it would be 2457. We can think about 457. We can rotate that any way we want, and then place a 2 anywhere we want. So does that help us? What is the... What's the right way to think about this? S0MF, what do you mean by brute force approach here? I mean, n is up to 100, so you can't just do n factorial or anything like that. Or 2 to the n, nothing exponential. Oh shoot, let me look at what's happening. Okay, I think we're back. Not like this. All right, we're back. Okay, I'm gonna make a quick restroom break and we'll be right back. Hello, Yazin003. We are just doing an ARC, AtCoder Regular Contest, problem F. So you can find my YouTube channel here. And then also you can just find the video in the Twitch videos. You can even find a replay of the current stream in case there's something that you wanted to look at again. Okay, so yeah, I guess I'll think about this a bit longer, and then if I'm not figuring it out, then I might just look at the editorial. I guess the discussion, because there's no editorial. Okay, so yeah, so the way I'm thinking about it now is, you know, you can pick a number and then you can basically rotate the rest of the numbers however you want according to its like or not the rest of the numbers, but it's kind of cycle when you jump by that number, jump forward by that number over and over. And then you can also kind of adjust that number itself and insert it into like a certain slot. And I wonder if we should think about like maybe a more general case with 12 numbers, because that way we have different prime factors and not just a power of 2. So what if maybe we can just make a random permutation. Maybe I'll do 6 for now, just to keep it a little smaller. Okay, so we have something like this. Actually, what if we go in reverse? Maybe that would be helpful. So what does the reverse operation look like? I think so. It looks like you take a number and you move it that much to the left. So like a reverse operation could be something like this. And hello, Mead 2018. This is actually almost the same as the other operations, so oh wait. Seems like very obfuscated version of Tower of Hanoi. Something like that, yeah, but Tower of Hanoi is an exponential. It requires like about 2 to the n moves, and so here that definitely can't work. I think we're looking for something about n squared instead. Yeah, I'm not sure how different it is. Maybe it's not that different to look in the reverse direction. But yeah, okay, maybe I can just throw out a permutation and try to figure out if I can get this to the sorted version. Maybe if I do some examples, I'll just figure out kind of a pattern. So actually, yeah, again, my thought process is like, what if we can do 1, 3, and 5? Like, just do all the odd numbers. Does that actually make things easier? Maybe we should solve for a prime n first and see if we can generalize that. That's kind of interesting. So yeah, so if we did this and we did the 1 twice, we would have 1 and then 4, and then we would have 5 and then 1, and then and if anyone needs the problem link, here's the contest. Then we can do the 5. So now we can have 4, and then we do that. So now 1, 3, and 5 are in the right places. Yeah, and so now we have this new problem where we have 4 blank, 0 blank, 2 blank. And so this is basically the same as like n equals 3 with 2, 0, 1. Yeah, and so now we just grab this 1 and we do it twice. And then we're good. And so that's interesting. So maybe we should focus on like prime n. I'll say this is f of x. Okay, so prime n. So what if like n equals 5? Then we'll just pick something here. Me 2018. Yeah, this is a hard problem. I did some easier problems earlier in the stream. You can check out the video if you want to watch some of the easier problems. But A, B, C, and D. Well, D was definitely somewhere in the middle of these, but A, B, and C were definitely more approachable, especially A and B. So you can check those out. Okay, so something like this. What do we want to do? So the thing that's interesting about when n is prime is that we have every number being relatively prime with n here, except for 0. And so we can just try to like kind of slide things around a bit. Okay, so let's see. If I focus on 1, then what I want to do is get like 0, 2, 3, and 4 in the right kind of order, relatively speaking. Like if we look at them, like if we ignore the 1, the first thing after 0 should be 2, the first thing after 2 should be 3, the first thing after 3 should be 4, and so on. So how would we make that happen? So we have 0 and 2, that looks good. We want 3 to be right after 2, so maybe we could do this. And then we want 4. Okay, this maybe we got kind of lucky here. But now we have ignoring the 1, we have 0, 2, 3, 4 in order, and then we can just put the 1 in place. So maybe if we pick, let's try another permutation. 2, 1, something like that. Okay, so let's get the 2 after the 0. So we'll do this, and then we'll do this. So now the 2's after the 0. We are on problem F of this contest. So this is definitely a harder one. Okay, so let's look at, then let's jump to 3. So we would have 3, 1, 4, 0, 2. So 0, 2, so 0, 2, 3, 4 are in the right order, relatively speaking. And now, basically, I'm just claiming we can do a whole bunch of operations on the 1 only to get it. So for example, if we do one op, we're like this. If we do another one, we're like this. I guess I'll just do about 5 times. This is when we started. And we do one more. And so this is what I mean about like we can rotate everything else. So 4, 0, 2, 3 became 0, 2, 3, 4. Right? And we do another full rotation, then we would have 2, 0, 4, 0. Yeah. It would become 2, 0, 4 and then 0. Or sorry, 2, 3, 4 on the right and then 0 on the left. Basically just 5 more would get us to this. And so that's why I want like 0, 2, 3, 4 in order in like a relative sense. Yeah, so it seems like you can always just do it. I still don't have like a good general understanding of how you do that. Maybe let's just try some more. Or maybe we can try like 7. Let's do n equals 7. Okay, I'm getting to a point where I'm like almost gonna bump into the Twitch chat. Maybe I will move the Twitch chat over. We'll just okay, that should be better. Okay, so yeah, let's try some permutations for 7. 5, something like that. Okay, so now we want 0 and then 2, then 3 and then 4. Okay, so let's do, I guess let's just move the 2 around until it gets there. Okay, and then the 3. So this is, yeah, this is a case that I hadn't run into before. If we move the 3, it like kind of kills the 2. So how would we get the 3 to be here without killing the 2? Oh, maybe we can just keep using the 1. And so in this case, we can like do that, right? Oh, not sure how much that actually helps. It definitely feels like we're halfway to a solution, though, if this is the right thought process. Okay. How do we get the 3 to here? Well, one thing, okay, I'm not sure how general this is, but one thing we could have done here is we could swap the 3, we can do the 6, and that gets 3 here, and then the 3 can jump to where it needs to be, which is here. And now the 4 can also jump straight to here, and then the 5 can also jump here. And then we just kind of got lucky and we got the right ordering we want. Yeah, we definitely don't have something general enough yet, though. This can get us to... I guess technically the virtual is over. Okay, in that case, I might just call it a day on this contest and look at what other people did. I guess it's in this. Yeah, okay, so this is what I thought. He copied his 5-year-old submission to some problem and then fixed it a bit. Oh, this is really funny. Okay. Right, there's one. Oh, right. Right, this is like, there are some, there's some different ideas on permutations. It's, I think there's one that's like, I think the probability that any particular element in a permutation, or, wait a second. No, the expected number of permutations the expected number of cycles of size k in a permutation is 1 over k. I think that's right. And so there's a 1 over n chance that the whole thing is a cycle. Yeah, if you just assume random operations gets you random permutations, then there's a 1 over n chance of it being one big cycle. If it is one big cycle, then what do you do though? Or you can use 0. The hint is, suppose P contains 1 through K as a continuous subsequence. Try to get 1 through K plus 1. This is the right, okay. Okay, yeah, so this is roughly what I was thinking. The 0, 2, 3, 4, and so on. I guess the 0 kind of doesn't matter that much, but he has the 1 adjacent, which is interesting. Like if we have a 1, 2, 3, 4, 5 somewhere and we want to get a 6, how would we do that? So like we kind of want 6 to go here. Maybe let's do that. Yeah, how do we get 6? I'll put in some more numbers here. Okay. So we have 1, 2, 3, 4, 5, and we want to get the 6 in the right place. Just magic. Okay. Okay, I'll spend a little bit longer trying to figure this out. Otherwise, I may just have to take a look later. I was thinking about, just for fun, maybe doing a couple of chess puzzles on stream. Put in the chat. Okay, so yeah, 1, 2, 3, 4, 5. How do we get the 6 here? You move the 1 around. Yeah, exactly. Variety streaming. Yeah, I'm actually stuck on this part. Does anyone see how to get from 1, 2, 3, 4, 5 to 1, 2, 3, 4, 5, 6? Like the goal here is somehow to get something like something like that. We don't really care what the other things are, but we just need to get the 6 over there. Maybe we can see who points to the 6. The 11 points to the 6, so we could swap those. Okay, but what if, I mean, what if like we had this, then does anybody point to 6? 9 points to the 6, I guess. So now I think nobody points to the 6. Yeah, maybe I'm just missing something, but I'm not actually seeing how to do this, obviously. I did want to, okay, I want to understand this better, though. Solve by using only 0. So what does 0 do? So I think one big cycle, does that mean... Does that mean I points to pi, or does it mean I points to I plus pi? No, it must be I points to pi, because p, whatever p is 0, otherwise would break that. So I points to pi, so if it's like... points to like 1. Is this a cycle? I think, okay, this should be a cycle, because 0 points to 5, 5 points to 3, 3 points to 2, 2 points to 1, 1 point to 4, 4 points to 0. Yeah. And then you can solve by using 0. Uh-oh. Okay, hello? Are we back now? Okay, I think we're back. Phew, oh, we only have 90 seconds. What do you mean by that? What happens after 90 seconds? Oh, I see. The VOD will be just, yeah, that makes sense. Okay, so it's until it's a big cycle, and then solve using only 0. Solve using only 0. What exactly is solve using only 0? Maybe we can find TFG submission. Okay, yeah, let's check this out. So basically, okay, makes sense. 1,000 random ops. Those you find inverse of 1. Why are we doing 1,000 random ops? Oh, if it's 0, return. Okay, sure, it's fine. So so we basically randomize it, then find where the 1 is. Find where the 1 is. Swap 1 with the 2. So if we had this, we would take that and we would swap 1 with the 2. Then we would swap the 2 with the 0. And then we'd stop, and then we'd go again. Oh, is this the idea to, oh, I see. So maybe like this, what we do here is we do the 1 and the 2, then we do the 2, and then we do the 3. Keep going. Oh, this way we can just like shift. Oh, that's cool. Okay, we can shift the 1, 2, 3, 4, 5 over. So we went from basically here to here. And we can do this until the 6 is at the right like relative position in order to jump to here by itself. Okay. Yeah, I think I see the idea now, and then that makes sense. Okay. Should I code this now? Let me think. I want to do that now. Okay. I think I will actually code this idea up later, and then now just for fun, we'll just do some chess puzzles on stream. So yeah, if you're not into chess, feel free to head out now, but yeah, I'm just gonna do a couple for fun. Let's see. What do we want to do here? Maybe we can do see a game of chess. Well, I'm not personally like as into the games of chess, but personally I do like puzzles more. But if chat is a lot more into seeing a game, we could also do that. Maybe I'll just start with hang on, I guess I should move this Twitch chat. Okay, I can actually move it. Gotta find somewhere that doesn't interact or intersect with the board. Okay, so yeah, so I was just gonna go through some of these more slowly first. Oh, an error. What the heck? I'm definitely okay. Yeah, so this one really simple. Just take the rook. I think we have a checkmate if we go here. His only option was to go there, and then we have a checkmate. We have a fork here. attacking both of these pieces with the pawn. I think we just have a free piece here. Do we have any sort of checkmate? I don't see one, so I guess I will just take the piece. Is this too fast for people? Here I think we have a check, and I think that's just a checkmate. Pawn blocks, we take the pawn. Here it looks like a checkmate. And I will move the Twitch chat back down a bit. It's super high. Oh, we gotta hydrate. Okay, so here, oh, this is interesting. We're in some trouble here if we get attacked, but I think we just have a checkmate on here on the back rank. Here, I think we have just a promotion because he can't stop it because our bishop takes, and then he can't cover the square with this bishop. So I think we're just able to get the promotion square. Here we've got a fork where we attack the king and then attack the bishop, and so king moves out of check, and then we just win the bishop. Oh, so now we don't actually want to take the bishop because, okay, so I actually missed this, but it was still the right move. We don't want to take the bishop because the knight will take our queen. We can't take the knight either, but what we can actually do is take this, and then we have another fork between the rook and the knight. So that was kind of funny because I had the wrong thought process, but it worked out. So the rook is covered now, so take the knight. Here, I think this is a little trick where like you kind of want to think about these rooks lined up a bunch and then think about checking, but that's not going to work because he's just going to take. It's actually just a checkmate by going here. It'd be fun if I take water only after someone redeems hydrate. I don't know. You guys would eventually, if no one redeemed it, you would end up just hearing a very like raspy voice. I don't know if that would be super fun. Okay, what do we have here? Oh, I think this is one of those tricky ones where it's like usually the things that I look for are checks and captures and very like forcing moves. One example is like something like taking this would be a very forcing move because you check the opponent, but he just takes your queen, and so that's not actually a good move. This one, I think it's an instance of a more quiet move where I think it's just rook to a7 because that sets up checkmate here, or potentially a strong attack here, and there's not really a ton he can do about it, I think. Maybe he can go here, but then we can just push here and check. And yeah, maybe he can run away a bit. Oh no, actually he can't even do that. So yeah, this basically blocks all his options. Yeah, so we just win the queen. Okay, so here the opponent has a lot of pieces. So yeah, it's like he's up, or he or she's up, a queen and a rook compared to a bishop, because 2 queens is quite strong. So we almost definitely need to find some sort of checkmate. Like, I don't think this is a good enough move. The first thing that comes to mind is this, which forces the king into the corner. And then we can't do this because the rook is covering, but we can checkmate here. Okay, here. I think here we can kind of just set up for a back rank mate. We can just push the king forward and then cuts off all these squares for the king. And so even if the king moved here, this would be a checkmate. This rook is stuck because of this pawn. And so there's not much you can do. You can push this, but then I think we can just push the pawn and cover that square. Yeah, so we can't actually do this yet. We have to take this first, and then we take this. Yeah. Anand, what do you think about doing a 1v1 puzzle battle after this? So anyway, so what I'm thinking is just check. I'm not sure exactly what to do afterward, but it just seems like the right thing to do. And then we have another check like this. And there's got to be something strong enough here. Maybe like check here and then go here. Yeah, I think that's what we're looking for. Me versus Anand 1v1 lockout. Yeah, I mean, that's also something we could do. So here I think it's just take the queen, they have to take it back, otherwise we just got a free queen, and then we take the rook. I mean, we have this free rook. Oh, no, we don't. No, we don't. Because of this. Oops. But what we can do is we can fork the king and the bishop, and then take the bishop, which removes the defender, and now the rook is hanging. Okay, yeah, here we can take this, but the king can take it back. And this is another remove the defender puzzle where we just attack the king. If the king takes it, we have a free queen. So the only thing the king can do is go here, and then we can just attack the king again. And then we get the queen. Actually, are you still here, Anand? I think this is just checkmate. Here we put the bishop here. We have a fork between both of these knights, and the problem is then he can take our knight, and then we take his knight, and then he takes our rook, and so we're not actually up. So what we want to do instead is trade off these knights, and then fork the rook and the knight. Let's see, we've got a check here. Okay, we've got a check here. If he goes here, we can move out. We have a discovered check, and we can take the queen. If he goes here, then we can pin the queen to the king. We have a hydrate. And actually, oh, we can't take with this because it's the pin. So yeah, just trying out some chess puzzles on stream. Okay, let's see. So this square is blocked off for the king. I think if we go here, we just set up this checkmate, and it doesn't seem like they can get out of it. So yeah, that's the idea. Is there anyone in chat who has a chess.com account and would like to puzzle battle? If so, let me know. Okay, so I'm noticing these queens are lined up, and this queen is not defended. So actually, if we just did kind of a sacrifice the knight and do a check here, then that opens up this queen to get taken. And even if he takes with the queen, we can just take back the pawn. There's also this check, but then I think... Yeah, the reason that's bad is because he can just take up the rook, and now his rook is covering the queen. So we want to go here. Maybe they are scared because you are too good at chess. But I'm not actually that good at chess. I guess I'm good at puzzles. So that's true. But okay, I could also play like an actual chess game with someone in chat, if anyone is down. Not actually sure about what to do here. We have this kind of X-ray, but there isn't really anywhere that's great to move the bishop. I guess this is actually interesting because this is a double check, and so the king has to move. And if the king takes, then we actually win the queen. So if we do this, the king can't go here. The king can go here, but this loses the queen, so we'll just mark that as bad. Can't go here. Anand sent me a puzzle link. I don't know if you heard earlier, but I was challenging you to a 1v1 puzzle battle. I feel like it's this. I'm not sure if that's right. What happens if he goes here? You muted the stream to try to do Puzzle Rush and see what you got. So I'm doing survival right now, so it's not timed. What did you get on the... Did you do 3 or 5 minute? High score. Oh, okay, yeah. 5 minutes time. Oh, I see, yeah. Mohmahkho, yeah, we could play. I guess, okay, let me just finish this puzzle and maybe I'll check out Anand's link. What is going on here? I'm not actually sure about this one. Maybe that. What do we do if he goes here? I don't know if I have anything there. Also thinking about this, but then I just lose the knight. So that doesn't seem great. I guess let's just try this. That's not right. Okay. One nice thing is you can review after you missed it. So, oops. That's not what I wanted. I guess I'll just repeat what I did. Okay, and then go into analysis. So it's bishop here. Oh, that's nice because the bishop going here cuts off this square and the square for the king, and the king is cut off from here. So the king has to get onto the H file, and then you just win the queen. Yeah, so basically check, and then you win the queen. Let's see. Okay, what's the one Anand sent me? I think it's just this takes checkmate, and then if he goes here, checkmate here. Yeah. Is that one of the ones in your puzzle rush, Anand? Oh, sorry. What's the checkmate if they take the rook? So yeah, here, takes, and then checkmate. Because this score is covered. Oh, you're not a premium member. Okay, I see. Oh, did you, mohmahkho, did you challenge me? Okay, sure. I think you're a bit better than me, so I guess we'll see how this goes. Are you cool with 3-2? I'll send you a challenge there. Am I having connectivity issues? I'm not sure what's going on here. I don't see anything in my challenges. No alerts. Why is there a 1? Oh, you also had issues on it? Oh. I sent you a 3-2 request, mohmahkho. Do I have to cancel this one? Okay, here we go. Okay, the Ruy Lopez. Let's take that. I don't actually know if this is good. I'm just trying it out. Let's see. Okay, I guess I will back up. Mm-hmm. Mm. It's funny, you can see my pre-moves. I don't think it will matter too much here, but... We'll do that. Oh, also, thank you, Deuce One Belly, for the bits. Somehow I missed that last time. 100 bits. That's awesome. Is this good? I don't know. We'll just see. This is mohmahkho in chat. I think I just won this pawn. Hmm. Here, then I take. This blocks my bishop. Okay, I'll just go back. I should castle. Hello, Anubhav. Hmm. Gotta hydrate. Oh, I'm gonna run out of time. Okay. Start doing this then. If you all redeem hydrate, you can flag me. Yeah. Trying to get my rook. Oh, I have 3 seconds. Okay. I gotta pay attention to my clock now. Nope. Alright, I flagged. Yeah, this is why I didn't want to play no increment. I even flag on increment. Yeah, GG's, mohmahkho. Do I know Georgian programmers? Not sure what you mean by that. Do you mean by, like, people from the country Georgia? Not too many, but maybe I know one. There's one called Nika. I believe he's from Georgia, at least. What do you mean by delay on the stream? Do you mean like the audio and video aren't synced up? Oh, you mean the game and the stream art? Yeah, that makes sense. Right, I want to check out this game report. Oh, this is a mistake. Wait, why is that a mistake? What should you be doing here? Okay. Yeah, I don't really like playing against the Rui Lopez that much. Oh, you should just take the knight. That is funny. So I'm actually in the lead here, but then I didn't take advantage of it. That's a mistake. Right, because you just have that. Oh right, I just gave up this pawn basically. Okay, makes sense. Is there anyone else in chat who wants to play or who wants to puzzle battle? If not, I might just do a puzzle battle against someone random. Typewriter maybe another time. Okay, I guess for now, let's see. I'll do a puzzle battle against someone on here. Hmm. Okay. Oh, my queen's just hanging. Oh, looks like I already won. Okay. Guess I'll just do 30 seconds more. I'll do this. Kids. Wait, what? What is this? I don't know what this one is. All right. Oh, we just put more pressure here. I see. We put a pin. Okay. I got a challenge. Was that someone in chat? Who's here? Let me see. Oh, the GitHub repo. That's just where I put like my contest code. Wait, Neeks, did you call me Nick? Or are you talking to someone else? What medal would I take now? I don't know. I've never like really had a chance to like do an IMO. Yeah, I'm not really sure. Probably not super high. Maybe like bronze or something. I don't know. I missed the hydrate. It's true. Yeah, I saw someone challenge me. Are you still in the chat? I'm not sure where I find the challenges that I received. Oh, there's a little delay. Try refreshing and see if that helps. If not, let me know, like, is the audio too early or is the audio too late? Cyanide222 says it's looks fine to them. Yeah, I missed the challenge, but not sure if they're still here. Okay, maybe I'll do one more battle. Yeah, if you want to challenge me to a game, just let me know your username in the chat, your chess.com username. Oh, excuse me. Oh, I misclicked. Yeah, mouse slip, Kennedy. Oh man. What is this? Ah, yes. Yeah, here we go. Animate. Oh, this one's tricky. Okay. There's the pin, so you can't take the queen. This is just mate. Just mate. Okay. Oh, pin again. Okay. Yep. Oh. Luckily that mouse slip wasn't possible. Check and then pin. Or not pin, fork. What is this? Right, I think it's something like this. Yeah, my opponent's getting pretty desperate. He needs to make up 4, now 5 puzzles. I'm not sure what this is. Check, and then... Okay, well, I guess I still won, but... oh no, this one's just a slip. What is this? Yeah, I don't get it. What? Does anyone see it? Maybe you do this, and then if he takes, you win the queen. And then... I guess if he goes here, you just start to promote. Okay. Okay, I'll probably do just a little bit more and then end the stream for today. Is there anyone in chat who wants to play? What about you, Gennady? Do you have a chess.com account? Okay, sure, Anand, let's play. There's a weird bug where I can't... Okay, I updated the title. I had to like change the time to update the title on Confucius. It's balanced. Okay, I'm not sure what happened if the stream cut out there. There's balanced odds. This is funny. So it tries to balance out the game based on your rating difference. You wanted 5. There's 5-5, 3-2-5-5, or just 5-0. I guess we could also, maybe we could just make our own. If you want 5-3, we can do that. Cool, that worked. Okay, let's go. I think you're underrated on here, right? So I think you're just gonna destroy me, but that's fine. Okay, let's try this. Did I miss something? I think this just works. Oh, no, I guess you can. Okay, wait. I guess you have some options. Yeah, you have that. So I don't actually win a piece. I can actually keep the queens on the board, but let's do that. Push. Trying to be a little cheesy here, huh? Bishop h6. Oh, instead of taking the queen? Well, he doesn't have to take you then. He can just hold it there. Yeah, I guess this push was a mistake. So I gotta cover this somehow. I mean, I can do this, but then I guess I can at least do this. So hit that, cover that. Okay, mess up your pawns. Oh, Anand would also have had checkmate here. I think that's right, yeah. Yeah, that's a good point. Good thing I didn't do that. Not trying to get scholared on stream. I guess we'll just go for that. And now we castle with check. That's exciting. Yes, protect your pawns. Yeah, so what I'm hoping here is, you know, Anand's pawn structure is kind of messed up here, and that will help me out. I guess I can... Should I double up? And then he can just go and cover it. So... this... Yeah, I guess I'll just double up. Seems fun. I could do this and as a Zug. I think that's what it's called. Swice. It means like in between move. Actually, okay, Anand's thinking for a long time about this. What are we thinking? Okay, he doesn't want to. Oh, did I make a big mistake here? Yeah, now I can just, maybe he can just check me forever. Or maybe I just lost? I don't know. Yeah, definitely shouldn't have let this happen. What's harder, LGM or chess GM? That's a good question. I don't really know. I'd say they might be pretty similar actually, but it's hard to say. I'd want to say that LGM is harder than chess GM, given the like different numbers, like how many chess grandmasters. But then on the other hand, there's probably a lot more people who have like tried out chess than competitive programming, so it's hard to compare. Anand's trying to figure out how to checkmate me. Okay, if he does this, I definitely should not go here because that would just be checkmate. Hey, that's not fair, Anand. Alright, I'll do it on your turn. Okay, I don't love this, but I guess I can just do this to kind of save myself. Yeah, Anand is totally cheating, right? Just wasting my time. Yeah, he's stream sniping me too. He knows when I'm about to pre-move. Now he's trying to cheese me. Keeps trying to cheese me. Maybe that's not actually good. I might be losing now. Yeah, the position Kennedy was talking about with bishop h6 is very interesting. I think it'd be cool to go back and look at it later. Wait. Oh, shoot. Alright, I was talking too much. I was thinking about doing this, but I don't think that works. I think you can just go down another one. Nice one, Anand. I think you had the lead there at the end. Sure, I'm down, Kennedy. I'm also terrible at time pressure. I mean, I just clocked on a 5-3 increment. I mean, apparently we played pretty good according to the numbers. So, I think we were looking at this move. Oh, this is just bad because I think you just like. Wait, no, that's not it. What is it? Oh yeah, you just get hit here, right? I think that's the reason. It actually prefers... Oh, I guess it thinks both of these are fine. You have to get out of here. Oh, and then it just forces a trade, so... Stream's down for you. It looks like it's good for other people. So this is a mistake. Oh, I shouldn't do this. I should just castle. Wait, why is this so bad? Or like, why is castling so good? Wait, it has a +3 evaluation here, and then I do this, and then this, and then the evaluation gets worse. Okay, so maybe it doesn't know what it's talking about. Okay, yeah, it thinks this is pretty drawn. But yeah, then this is... Yeah, this is a pretty big mistake that I made here. Oh, but then you blundered? Yeah, so it's... I guess it's a draw, but it's still a draw this whole time. But the onus is on me to hold the draw, so it's tough. Anyway, yeah, I'm down to play Kennedy. What's your username? Is this someone in chat? Okay, I will run to the restroom and then be right back. Aha, here we go. Oh yeah, very back and forth on him. All right, I will challenge Unity. Okay, so we wanted 1-1. Well, what do you think about 2-1? I feel like I'm really gonna flag if it's 1-1. We can try it. We can try it. Did that work? What happened? All right. Yeah, I'm not big on bullet. Oh, what a weird opening. That is weird. Oh, I have to go way faster. Okay. I already ran out of time. I'm about to get it back ranked. Oh, there's the blunder. Oh, that wasn't good. Didn't take the knight? Ooh, might be in trouble here. Alright, we flagged Kennedy. We can go again if you want. That got pretty bad toward that. I think we spent too long in the beginning. Yeah, definitely some blunders. Yeah, I rematched you. It's just being weird. Okay, not that d4 is weird, I just don't usually play it. He really likes trading queens. Oops, maybe I didn't think this through enough. Oh, I had... Alright, this is safe, I think. Try to do that. Go back. Oh, no. Alright, we both flagged once. This accuracy was much worse. Alright, we gotta do at least a best of 3. 44.4 is pretty bad. I have to hydrate? Alright. Anand was using this earlier as a way to distract me when I was playing against him. Okay. Kenny really loves trading queens. Oh, that was good. Oh, did I just hang that? Oh, wow. All right, nice. Are you underrated, get any on here? How much have you played? Yeah, these games are pretty bad. I agree. I'm trying to figure out if Gennedy's underrated so I have an excuse. But it seems like he plays a lot, so maybe I'm just bad. Yep, GG's. Yeah, sounds good. I think I will probably wrap up the stream actually. I see Het P challenging me. Wait, I feel like I'm getting rating farmed. Why is this rating so low compared to your rapid? All right, I'll play one game and then I'll go. Yeah, thanks for the games, Kennedy. Are you still here? What game is this? It's definitely not Code Forces anymore, or AtCoder or whatever. Okay, he's trying to cheese me too. I don't know. Is the rook a person? Do we have something better here? I didn't have to do that actually. I could have just waited. Crap the juicers. Yeah, exactly. It's very Hikaru. Yeah, you can see the engine's analysis afterward. Oh, yeah, that was the one move you shouldn't have done. Yeah, you can just click this. I think you might have to have a premium account to do that. But yeah, you can check out the analysis here. Oh, so not only is this cheese, it's actually like bad. I guess it exposes too much of the king. Yeah, only premium account makes sense. Without the hydrate. Oh, thank you, Sneak Toggled, for the bits. Oh, I guess that was a while ago. Okay, it's these ones. That makes sense. Almost got cheese. Yeah, we both kind of almost blundered straight into mate. And then I guess at the end, actually at the end it did happen, but yeah, GG, head P111. The temperature, now this is my CPU temperature, so like, this one is the hottest CPU core, so these are the 6 cores, and then I have like free memory and a couple other things. Yeah, so one thing that's cool is like if well, I guess we'll take an example. If I run like I guess this is not that good of an example because it's too quick, but you can see like the temperature shoots up for a sec when it runs. Like when the CPU is doing stuff. Oh, maybe a better example is like if I do some multi-threaded stuff. Yeah, it's like, then it'll use all the cores. You can see it's really running hot when you do that. Yeah, so this is kind of, like 90 is getting a bit high. You don't want to go that high too often. You should try to keep it under like 80. The reason it's in the 70s right now is because it's doing a lot of work for streaming. If it weren't for the streaming, it should normally be more like in the 50s. Yeah, you can definitely hear it. Yeah. Like when you're running this stuff and you're just using all the cores, it has to cool itself down. So the fans are really going ham. Yeah, FFT. I've actually heard that there's something called, or there's some different like CPU tests. I think one of them is called Prime 95. I'm not sure if this is the one I was thinking of, but this is like how they test CPUs and make sure that they're operating properly. And maybe this isn't the right one, but there was one where like it literally just runs a bunch of FFTs and then the CPU gets super hot. Yeah. Anyway, I think I'm gonna call it a day for the stream. Oh wow, it's been like 4 hours. Is Linux difficult to use? I think Ubuntu is pretty easy to use, but it definitely takes some just getting used to some of the stuff and setting things up. Yeah, definitely like give it a try at some point. But yeah, it's been a while. Need to go eat lunch. And oh yes, you're gonna switch your laptop. Yeah, I would just give it a try first. I think you can make an Ubuntu USB and then just like try it out without actually installing for a little while and see if you like it. Vertical tell, yeah, I will try to do some more contest analyses. I noticed that there aren't any rounds for a while, so I'm not sure when the next one will be. Oh, they're actually, okay, I see some now. There's one on Friday. Okay, I might be able to do that. Yeah, we'll see. And yeah. Yeah, thanks everyone for coming to the stream. Follow my channel to know when I'm going live in the future. But otherwise, I'll see everyone next time. Is there any... Let's see if there's anything to raid. Otherwise... Okay, yeah, I don't really see anything right now. So yeah, I'll just see everyone next time. Thanks for coming.